All right. Like I say, let's do the ones from the book, like the arc sine, arc cosine, some of that stuff. Any of those you want to talk about? 21. Was that the arc secant one?
Yeah.
Yeah. Okay. So was it f of x or y or what did it say? F of x. F of x equals arc secant of x over 2, right? Which would be this, yeah, x over 2. All right. Now, reminder on the derivative rule. So before we get into this one too much here, so let's talk about the derivative rules. Now, again, I want to make sure everybody's clear. Okay, we had some of these basic rules. We had product quotient rule. Now, the u here, and we've used u now a couple different ways here. The u on this is just, well, in a sense, the same way. U stands for some function of x, right? So this, we could write this f of x times g of x, right? But u and v just stand for functions of x. So that could be sine x, e to the x, whatever, some function of x. So if we multiply two functions, there's a product rule. Quotient rule if we divide two functions. Okay, chain rules when you have something inside, which happens all the time, right? I mean, a lot. That we have something inside of a function, inside the e functions, inside ln, inside the sine function, inside the power function, right? Inside an arc sine function like we saw today. So the chain rule is just, hey, you got to do the derivative of the outer function, you got to leave the inside in there, and then you have to multiply by the derivative of the inside. Well, that's what the u's are in all this. So I don't want, I get a sense in some people I've talked to that they think that this is a whole bunch of new rules we have here with this u prime. Oh, you got to do the u prime. The u prime there is just what? The u prime here is just what? What's that represent in all these? The derivative of the inside. That's all that is. That's the derivative of the inside. Okay, so what this is saying is the stuff, yeah. So this is saying if you have some stuff raised to a power, that stuff is on the inside. So you do the derivative of the outside, which is the power. You bring the power down, you leave the inside alone, you decrease the power by 1, and you multiply by the derivative of the inside. Here you got e raised to some stuff. That stuff is on the inside. So the rule is e to the stuff, and then times the derivative of the inside. Okay? Same thing here. Same thing here, right? The stuff is on the inside. So we have to tack on, the chain rule says we have to tack on the derivative of the inside. So in all these rules, the u prime is just doing the derivative inside. So you don't have to think to yourself about the u prime necessarily. Now, sometimes people like it. It's helpful to think of, what the u is, the inside stuff. And so we come over here, we got arc sine, arc cosine, arc tangent. Now, the problem is there's no arc secant rule, right? I mean, there's no arc secant rule, so how do we do arc secant? Well, it goes back to this. And this is what I was telling some people this morning. So if I told you that cosine of x was 3/5, what would secant of x be? 5/3, right? They're reciprocals. Their outputs are reciprocal, right? Now we're talking about the arc secant function. So how do arc secant and arc cosine compare? Arc secant and arc cosine are kind of paired together, right? Secant and cosine are reciprocals. Now we've said that, you've said that ever since you learned about them last year. Secant and cosine are reciprocals. But what did you really mean when you said that? What you really meant was their output values are reciprocals, right? But if we're talking about arc secant and arc cosine, we're talking about the inverse function. And what did we say is the number one rule with the inverse functions? Where do they come from? You interchange the x and the y, which is the input and the output. With inverse functions, you interchange the input and the output. So therefore, if secant and cosine have reciprocal outputs, arc secant and arc cosine have reciprocal inputs. Okay? Because the input to sine is the output of arc sine, and vice versa, because we are interchanging those. So this function is exactly the same function as this function right here. Those two are exactly the same function. Okay? So that's why we don't have a rule for arc secant and arc cotangent and arc cosecant. right? Because we just do that. Now, I don't anticipate asking you one of those on the gateway test. You know, again, unless that's one of the hardest of the hard ones. But I really just, you want to know, once you know arc sine, arc cosine, arc. Okay? But it's a fact of trig and inverse functions that we should become familiar with. It's a tricky thing, but that's why I thought some of this stuff in this section is important to go through, because we're going to see it again. Inverse functions, those kind of things are going to come up. All right, so now, if I'm going to do the derivative of this, I'm going to want to probably write that as 2x to the negative 1 first. Okay, so now all I've done is rewrite this. Now I'm ready to do the derivative. Now the derivative rule is 1 over the square root of 1 minus u squared times u prime, right? The derivative of the inside. Or no, with cosine it's a negative up there. Okay, so my derivative is going to be negative 1 over the square root of 1 minus, here's where I think the u can kind of be helpful. This is the u, right, the inside. So when we do a chain rule on this, when we say, okay, the derivative of the outside, well, the derivative of arc cosine is this, right? Leave the inside alone. Well, right here is where we're leaving the inside alone. We're putting the 2x to the negative 1. That's the part where it says leave the inside alone, right? We're putting the 2x to the negative 1 there. And then we have to times by, as we always do, we have to times by the derivative of the inside. That's what the u prime is. Times by the derivative inside would be negative 2x to the negative 2. Now, I think you ought to clean that up a little bit. The negative 1 times the negative 2 for sure you could do. I would just put all that up top like that. And then this, you know, you might as well square this thing. I mean, that's pretty easy. 2 squared would be 4. And then power on a power you multiply, so that's x to the negative 2. But I wouldn't do any more than that with it. Now, we were discussing this morning, could you just leave this quantity squared? That's fine. On the arc sine, arc cosine, we got the u squares down here. If you just want to put it in parentheses and square it, afraid you'll mess that up, that's fine, because we're not going to do any other simplifying with that. You can't square root that, right, because of that minus sign there. But the negative 1 times the negative 2, that definitely you should do. Okay? And again, this x to the negative 2 could flip to the bottom if you wanted to. I think you look at the back, they do all, then they put it inside the square root somehow, and they do all kinds of goofy other algebra simplifying that we won't worry about. Okay? It's mostly just kind of rearranging stuff. All right, what else? What else? On the in the arc sine page, arc cosine page. Nothing? Okay, how about page 195? I'm recording both classes today, so if you're sitting there and have a question and for some reason don't want to ask it, maybe somebody will ask it in the other class and wants that recorded. Anybody on 195? Number 19. Tell me what the function is. Okay, so f of x or f of x. Okay. Okay. Which one is this? Thank you. Okay. All right. So first thing I would do is bring that x up as a negative 1, right? Because we always like to have power, because it looks like there's going to be a power rule. Okay, so this reminds me of the rule e to the u times u prime, right? The derivative of e raised to something is e raised to that something times the derivative of the inside, right? The inside is this here. Okay, so the derivative would be it'd be that same thing, times the derivative of the inside. So the derivative of that would bring the negative down in front. That'd be positive 2, x to the negative 2. Stop right there. Now, you could, there's no plus signs or anything in here, which is good, so you could flip that x down the bottom if you wanted to, move the 2 around in front, you know, what was causing the trouble in that form? Yeah, because, well, here would, yeah, so that greatly helps, right? If you wouldn't, okay, let's talk about that. Because let's say you're on a gateway test, whatever, and it frees up and you don't think of x to the negative 1, right? Put it there. So what would be your other option? Well, you would just do this. So you'd say, you'd leave that as your use. So you'd say, okay, e raised to the negative 2 over x, and then times what? The derivative of the inside, right? And now how do you do the derivative of that then? Quotient rule, right? You might look at that and say quotient rule. Now, again, my advice is we avoid the quotient rule if we can, right? The only time I would do the quotient rule is if I got some x's on top and some x's on the bottom. If I have just a constant on top, if only my x's are on the bottom, then I would swing those up, right? Or if I have only a constant, so in other words, if I have 2 over x, every time I'm going to make that 2x a negative 1. And if I have x over 2, every time I'm going to make that 1/2 x, right? So I can avoid the quotient rule, all right? And that includes if I have something complicated, like if I have 2 times x plus 1 quantity squared, I'm going to swing that up and make it 2x plus 1 to the negative 2, and I'm going to do my chain rule with it, okay? Anytime I have just a number on top or just a number on the bottom, I am going to rewrite those so that I do not have to do the quotient rule. Now, you might love the quotient rule and want to do it every time. That's up to you. I don't care, because it should work. It should work, so let's do it. So, let's do the quotient rule. The quotient rule says derivative of the top, which is, this is the part people usually mess up. This is why I say avoid it. What's the derivative of the top? 0 times the bottom left alone, minus the top left alone, times the derivative of the bottom. What's the derivative of x? 1. All over the bottom square. Okay? So this becomes 0 plus 2. So it would become 2 over x squared. So we have e to the negative 2 over x times, what was that? 2 over x squared. Right? And is that the same as what we have here? It's the same thing. Right? So I'm fine. I mean, that's fine. Yeah, that's no problem. Do that. It'll work. It should get you the same thing. The key is, do you do the quotient rule? You know, I mean, that's the main thing. As long as you do, you should be fine. Okay, what else? 16. What's that one? T cubed cosine t, and it would be to the 1/2 power, correct? It's a square root of it. Okay, so that would all be to the 1/2 power, and so this to me is this rule, u to the n, right? It's some stuff raised to a power, so it's going to be n times u to the n minus 1 times u prime, right? So I'm going to bring the power down in front, so let me get over here. So g prime would be 1/2. I'm going to leave the u, the inside stuff, alone, to the negative 1/2, and then I'm going to times by the derivative of the inside. Now here's where I would put a big set of parentheses, and I'm now going to look at just that, right? Might even stop, take a deep breath, go into the fridge, grab some drink, whatever, because I've got some work ahead of me, right? In other words, that happens sometimes when you're doing one of these and the inside stuff is kind of messy. The inside stuff. So when you get to this u prime step, sometimes there's more work to do there than the whole rest of the problem, right? You do the derivative of the outside, leave the inside alone, and then it's like, okay, now I got to do the derivative of the inside. Okay, so big set of parentheses because there's plus signs in there, so that might really matter, right? It might really matter. If I just put a dot and then start working the derivative of the inside, this is what worries me, is people do this, and then they say, now I'm going to do the derivative of the inside. Okay, they put a big dot, and then the derivative inside is 2 plus 3x squared minus 7x or something. Well, is that good? That's bad, right? Here's the derivative inside. You've got to be timesing by that whole thing. All you did was times by the 2. So I put a big set of parentheses to contain what I'm about to do here. Okay, so I'm about to do the part in red, derivative of that. Now, the plus sign actually ends up going away because derivative 1 is 0. So now I just really have this is all I have. What do I need there? Product rule. So the derivative of t cubed is 3t squared times the cosine left alone plus the t cubed left alone times the derivative of cosine. What's the derivative of cosine? Negative sign. And here's where I always worry about people now putting negative sign and make it look like a minus sign. And that's not what we have. It's times this. So I usually take that negative. Whenever I do cosine, the derivative is negative sign. I'm going to stick that negative there. And then sine t. And I barely left myself enough room. Now, is there anything we can do? Well, we got this. A couple things I said with algebra you want to be careful of. Anytime you got a quantity into a power, you're a lot of times not going to do anything with that. You're not going to move stuff out of it, move stuff into it. So there's really nothing we can do there. Here, well, I've got a t squared I could take out, I suppose. But could I do anything with it? I couldn't cancel it. Usually we factor something out so we can then cancel it. There's nothing on the bottom here. There's nothing to cancel, so nothing would happen. Now, I would say, since I got this half sitting here, if I could pull out, say, a 2 or a 4 or a 6, right, or something like that, that I could then cancel with this 1/2, I would do that. But there isn't anything there I can pull out, so you're done. Okay, so once again, you're looking that there might be some simplifying or something you can do, but a lot of times you get done with that first step, and you're done. Okay? All right, good one. Another one. (17) E, what is that? T squared? R squared. Eyes are going. E to the r squared, which would be this. This would actually be in parentheses, even though it doesn't say it. And then time. Oh, and then the sine r is up in the top. Oh, so it's r squared times sine r. Okay, so that would all be in parentheses. R squared sine r. Okay. That. See, and again, they don't write parentheses. I'm going to be careful when I write the gateway test. I'm going to put parentheses where they need to be so it's clear where these things are. All right, so this is an e to the u times u prime, right? It's e raised to some stuff and then times the derivative of that stuff. So h prime of r would be e raised to that same stuff times, big parenthesis, the derivative of the inside. So let's do that in blue. So the derivative of the inside is that right there. So what do we need there? Well, we got to do the product here, right? We got two functions multiplied together. So the derivative of r squared is 2r. We leave sine r alone. Plus r squared left alone times the derivative of sine r cosine r. And there we go. Right? Now, can we take out an r? Sure, but it doesn't really do anything. If you pull out an r, you can't do anything with it. I wouldn't do it. Just leave it just like that. Okay? All right. All right, let's do one more, and then I'm going to throw some at you and let you practice here, and then I'll give you some individual work time to do some different things. Oh my goodness! Thanks a lot. Maybe maybe not have time. If I take it out. All right, LN. Did you try this one? You just want me to do it.
Well, I didn't know how to do it.
All right. Well, that's probably a good one to pick. All right, now, if I look at something like this, there's a couple things I would clean up first there, like the x times x plus 2, right? Because if I leave it like that, then that's a product, and I don't want, right? So I'm going to distribute that x through there, and I get x squared plus 2x. I'd rather do that. But then I got some x's on top, x on bottom, so there's going to be a quotient rule there. There's no getting around it. And then there's square root over all that, so that's 1/2 power. So I would do all that, and it's all inside of the ln. So let's see here. Make sure I get my parentheses right. I think that would be, I'd have something like that, right? And then inside of that would be x squared plus 2x. And then on the bottom, x plus 3. Right? Do I have parentheses all in the right places? So I got ln, so I got that all inside of ln. And then inside the ln is a square root, so that's all the 1/2 power. And then I've got that quotient inside. Okay, so this is just, all this is an lnu, an lnu rule, which is 1 over u times u prime. But like I said, the u prime is a bunch, right? You might have to go you might have to call out for takeout on this one. Just go to the fridge and give me that. All right, so you're going to have, so it's 1 over u, right? So 1 over the inside stuff. Now on this one, I might leave it as square root, but whatever you'd rather write. But so all that stuff on the inside, x squared plus 2x over x plus 3, all to the 1/2, right? The whole inside, that's going to be on the bottom. So it's 1 over u, and then times u prime. I don't think there's any right. All right. So now what? So the derivative of the inside, I'm just looking at the red stuff. All right. I'm just looking at that. So what do? I start on the outside. You know, it's like the old saying, how do you eat an elephant? You ever heard that saying? One bite at a time, right? I mean, this is the elephant of all elephant problems right here. One bite at a time. So you just start on the outside, 1 over that, get that taken care of. Then it's times the inside. So now all I'm looking at is that red thing. That's all I'm looking at. So now I've already got my parentheses, so I know it's in the right spot and everything. So I bring that down. I'm going to leave that inside alone because now what I got is a power rule, right? Which is bring the power down, leave the inside alone to the n minus 1, and then that inside. So I'm bringing the 1/2 down. I'm leaving all that alone. Oops. To the negative 1/2. Okay, so now I just did the power rule part of that right there. And now I'm doing the derivative of that inside. So I need another big set of parentheses inside those parentheses. Okay, so I got this times. Now I'm looking at the blue thing. Run out of color. All right, so now I'm just doing the derivative of that. Right, but if you just take it one little bit at a time, it isn't as bad. So now I got to do the derivative of that, which is a quotient rule. So the derivative at the top is 2x plus 2. Here's where parentheses become really important. 2x plus 2 times the derivative of the bottom. Oh, no, excuse me. The bottom left alone, right? Minus derivative, the top left alone. Oh, shoot, I got it right small. X squared plus 2x times the derivative of the bottom. Oh, good. 1. All over the bottom square, right? At that point, I'd say the heck with simplifying. I've done it.
We're done.
We're done. No, actually, you should do a little bit on top there. Let's just focus on the blue. Let's say you just had the blue one as a problem, which you could. I mean, that'd be in the easier category, right? On the gateway test, if I gave you just the blue as a function and just a plain old quotient rule, that'd be pretty easy. Okay, and what you'd have to do is do this. You'd have to FOIL that. So 2x squared would be 6x, 2x, that'd be 8x plus 6. And then distribute here, minus x squared minus 2x. So that whole top would end up being x squared plus 6x plus 6. Kind of hoping something might cancel, but it doesn't look like it's going to. You know, but that's where something nice might happen. You might be able to factor, maybe cancel some things. But we were able to combine some terms together, so it's not just rearranging. So the inside would have went to there. And then really that's about it. Now, you know, you really can't even, well, we could do some stuff with this probably, because what we have is we have this times, this is a little beyond this whole thing, what I would ask you to do. But let's look at some of the individual simplifying things and see what we could do. Because really what you have is you have this thing. Even though we did put this big set of parentheses, there are no pluses in here really, right? So it's really just this times this quantity times this quantity, right? So really, it's all of these individual things I can now put together. There's this in the blue, this in the red here, and then this blue here. So these two, I could flip this around, right? And make this that fraction to the negative 1/2 if I flip that up. And then I got another one of that very same fraction to the negative 1/2. So what can I do with that? What do you do if you have two things with the same power, like x squared, or the same base? X squared times x squared is x to the 4th. You add the power. So since we have two of the same thing here, this and this, to the negative 1/2 power, I could just put those together and that'd be to the negative 1. Right? So I could take that whole, so the square roots would actually be gone. Maybe the square root part of it would cancel out. So I could put those two together. So I'd have a 1/2, that to the negative 1, and then this piece, that piece right there. And then at that point, I think, well, wait, oh gosh, time out. Oh no, it's getting better. It's getting better. Hang on. Yeah. No. No, this is more fun. Look, now listen, what do you got if you've got x squared plus 2x over x plus 3 to the negative 1 power? What can you do with that? Just flip it. Well, what happens when you flip it? See, so you're going to have x plus 3 over x squared plus 2x. Now it's flipped, so now it's just the first power. And then this other one has an x plus 3 squared and an x squared plus 6x plus 6. And so that is going to cancel one of those. And that really did simplify quite a bit. Okay, so now it just ends up being that over that. I'm kind of curious. Type that one into your calculator. We got 20 minutes. Yeah, that was quite nasty. So we would have that on top, and we'd have a 2, and we'd have an x squared plus 2x, which we certainly could multiply out. I'm just curious if we did this right. While you're typing that in, let me foil this, because I'm thinking the calculator might do it. The calculator might put it in factored form too. I don't know. So the bottom could be, that. So if the calculator expands it all out, it might do that. Or if the calculator leaves it factored, did it do that? No. It's just like that, or did it take an x out of it? I'm guessing it would have taken an x out. There you go. That's good to know we did it right. Wow. That's a good one. All right. All right, so let's take a look at the websites, because this is where you could spend a decent amount of time practicing. Now, page 195 has a lot of good practice. Okay, Chromebook. Thank you for asking that. I mentioned this earlier to people, but nobody ever really pays too much attention until they actually have to write one. On your Chromebook, when you go to YouTube, to be able to see them, I think it is a safe mode. Yeah. So you did that? Okay. Okay, everybody, if you want to know about this, go ahead and pull your Chromebook out. Somebody showed me, I can't remember where it is. I think it's way down at the bottom of the YouTube page. Or maybe you have to go into settings or something.
Like the school accounts disable it from the activity.
I think you can, though. From what I've understood, people have been able to turn safe mode off and then they've been able to watch it. Because I know, raise your hand if you've watched videos on your Chromebook. I know some people have. Okay. Okay. So I think you can. I think you can. I think if you go to YouTube or go to the calculus site, maybe that'd be better. Instead of just going to YouTube, let's go to the calculus site and pull up. Maybe pull up. Of course, yours is going to look different than mine, I think. Let's go to, well, maybe you just watch it directly within the site. I don't know. Actually, I'm not sure. It's gonna look different on mine, so it probably doesn't do me any good to do it here, but. All right, so if we go in here. Like safety on or off? No, you can just
Mind if you just click it on the sideline, so it'll be right there.
And then if you full screen it, it's fine, so it's, okay, so what that's saying is you guys have a setting there that's letting you do it. Okay? Well, if anybody's not, where's the thing for the safety?
Yeah, you should. I have it.
There.
Click play and it goes.
And you went safety off, right?
Oh,
Anything off.
What's that?
Ours just went.
Right, but I think if
Yeah.
you look down at the bottom, well, if you're on YouTube, if you're down at the bottom, there's a safety, it says safety on, and you want, it says safety on, and you want to click on that, and you want to turn it to off.
Okay, there we
Safety
go.
off. Okay? So yeah, so if you're ever gone, if you're ever, and you need to be able to watch them, you should be able to do it on your Chromebook. Now, some people, I think, maybe watch on a home computer sometimes or whatever, but yeah, you should be able to watch them there, and they're quite exciting.
Oh, they're great.
They're good, yeah. They're a lot of fun. But all right. So anyway, so let's yeah.
So it just has a option.
You just click on it.
Yeah, I just clicked on
This
it.
well yeah, in safety. So in other words, okay, so let's just go to YouTube. Just go to YouTube.
Yeah, well.
Yeah, if there's an intruder.
Yeah.
Document and save
I think we're
Kill.
So
You have prison trips right here.
Yeah, one didn't
We were just-
there.
okay. We good? All right. So let's go through. Let's go through a couple. So get ready to go. So you can close the Chromebook. If you got it working, go ahead and close your Chromebooks. And let's go to David will be disappointed if Dad lets you get your Chromebooks out. He's not here. All right. So, all right. Oh, here we go. Perfect. So this is number 3. I would probably stop at number 3. Well, we could, but it's kind of a waste of time. I mean,
Let's try it and see if we can do it.
that just it's levels inside of levels inside of levels. Now 4, 4 sometimes isn't bad. Now another thing. Oh shoot! I wanted to go back to the. Oh, I guess I can't. All right, let me. Here we go. Here'd be a good one. All right, now notice I've only got like ln and e and sine and cosine clicked right now. Okay, and so you definitely want to, and we'll do that here on our next one. We'll click some of these other logs and like tangent and secant and some of those. Okay, we'll do some of that here in a minute. Okay, let's do this one. So it's 2 square root of x times sine of e to the x. Go ahead and try that one. 2 square root of x times sine of e to the x. All right. So, did I copy that right? Make sure before we get into it. Is that right? 2 square root of x times sine of x. So it's a basic product rule. It's a right? It's a product rule. Now it's got something goofy going on the inside, but we'll deal with that when we get to it. So product rule says derivative of the first, then leave the second alone. So bring the 1/2 down in front, cancels the 2. That'd be x to the negative 1/2. Leave the sine e to the x alone, plus 2x to the 1/2, leave alone. Derivative of this. Well, the derivative of this has a couple parts to it. The derivative of the outside, which is cosine, leave the e to the x alone, times the derivative of the inside. Derivative of e to the x is e to the x. And again, there's nothing we can pull out of there, nothing simple, nothing to do. So that's a medium to hard. It's not that hard because they're pretty basic derivatives and not hard ones to remember. There wasn't any simplifying to do. So from that standpoint, it's not that bad. Okay. So if we're just kind of thinking about what level it would be at. So I think I've typed it in here, and what happened? I had it typed in there. Oh, here it is right here. Oh, there it is. Good. Okay. Thank you. I don't know why I wasn't even paying attention to this. So I had typed it in, and it'll tell you correct. Okay? All right. Now, let's uncheck some of these, and let's say we want to work on an inverse sine cosine one. Okay? So there you go. Oh, that's too easy. That's too easy. Oh, that's not hard enough. Yowza. That's not an inverse trigonometry. What's... There we go. Do that one. 3 square root of x times arctangent of x. Three square root of x times arctangent of x. All right. So something like this, all right, just a product rule. 3 square root of x would be this. Arctangent would be this. So we do it's a product rule. So derivative first, bring the half down. 3/2 x to the negative 1/2. Leave the arctangent x alone. Plus, product rule is plus. 3x to 1/2 left alone. And the derivative of arctangent, that's just our rule for arctangent. Didn't have anything in the inside other than x. So it's just that. There's no, times of 1. You can say, well, what about the u prime? Well, the u prime is 1. All right? All right, now let's look at one more on this website. So what I've done now is I've clicked on the a to the x and the log. Anything in these 2 rows you should be able to do. Now notice it says polynomials, rationals, power functions, root functions, plus these. So sometimes you don't get, even though you've checked this box, you don't get it. You're always going to get some power rules, some quotient rules, some stuff like that. But I clicked on the a to the x and the log base a of x. So let's do this one. This would be a pretty difficult level 1. It combines some functions that we're not as familiar with, don't use as much, so you got to remember those rules. And then it's also got a quotient and a product, so it's got quite a bit there. So it's 5 log base 4, 5 log base 4 of x times x cubed all over 2 to the x. So we'll do this last one here, and then we'll go to the other website, and I'll show you what's going on there. And I'll give you some work time. Okay, don't look if you don't want to yet. I see a number of pencils down, which means you're done or given up, or maybe, right? Let's talk about it before I show you. So the main rule, where you're going to start is what rule? Quotient rule. This is a quotient rule. It's some stuff divided by some stuff. It's a quotient rule. So the quotient rule says you start by doing what? Derivative of the top. Oh, okay. Well, the derivative of the top, we need what? Product rule. So, quotient rule is derivative of the top, bottom left alone, minus top left alone, derivative of the bottom, right? So we got 4 pieces we got to do with a minus in between. The first of those 4 pieces is a product rule, right? So, we're going to do the product rule. So, we're going to do the derivative of that, leave that alone, plus that alone, times derivative of that, right? And that's just the first of those 4 pieces we were just talking about that the quotient rule has, right? So it wouldn't hurt, it wouldn't be bad, I know the video people can't see this, but as a quotient rule, when you get a complex one like this, right, this is what I got at the top of my quotient rule, right? Derivative of the top, bottom left alone, minus top left alone, derivative of the bottom. Now this one has got to be a product rule, so that's the first one I'm doing. So I always think it doesn't hurt to put parentheses it down when they're complicated ones like that to think about that. Now I didn't do that way necessarily here, but that's what we got. So if you think of the first, like I was just saying, if you think of this as 4 pieces, here would be my 4 pieces. Derivative of the top, bottom left alone. Top left alone, derivative of the bottom, right? That's what I did there. And then all over the bottom square. So backing up now and filling in those 4 parentheses, derivative of the top is the product rule, so I do the derivative of this first. Now the rule for log is 1 over u, right? The rule for ln is just 1 over u, but at another log it's 1 over u times 1 over ln b, the base, times u prime. And you've got to know that rule. So the 5 just hangs out there. The rule is 1 over u, so that'd be 1 over x, times 1 over ln 4, because that's what the rule says, times u prime. Well, the derivative inside is just 1, so that's good. We don't have to do that. Okay? Then times the second left alone, x cubed's left alone. Plus, I'm still doing my product rule. This left alone, 5 log base 4 of x times the derivative of x cubed, which is 3x squared. So there you go. That whole parenthesis was just doing the derivative of the top. We leave the bottom alone, minus, we leave the top alone, and then we do the derivative of the bottom, which is 2 to the x ln 2. Because the rule for something to the x, e to the x is just e to the x, but 2 to the x is 2 to the x, tack on ln 2. And the derivative of the inside. And then the bottom all squared. Now, is there anything we can simplify? Well, we can certainly combine some things right here, right? I mean, here's a plus sign, right? So we got to stop there. But right here, what could happen? What about the x's? Couldn't that x cancel one of those? Right? So that'd be an x squared. So right here, so just with that right there, I could have 5x squared over ln 4. Is that right? So this would cancel that, and that'd go together. Okay, now there's a plus sign. And then 5 times 3 is 15. X squared and log base 4 of x. So I could combine some things there. Then I've got this 2 to the x sitting there. Okay, oops, 2 to the x. All right, and then a minus. And now what about here? Nothing really there. Nothing really, right? It's just a bunch of stuff. There's no plus signs or anything. It's just I could rearrange it. Okay? So let me rearrange it a little bit. Let me put the 5, and then the ln 2, and then the log base 4. I should have put the x cubed around over there. That's fine. X cubed. What am I missing? 2 to the x? That wasn't very good rearrangement, but whatever. And then I got 2 to the x squared down here. Yeah, what about a 2 to the x? Because this first term here has a 2 to the x in it, right? I mean, I got this group of stuff, and then I got 2 to the x, I got this whole group of stuff. I could pull out a 2 to the x, which would get rid of this, and get rid of this, right? So I could pull out a 2 to the x and cancel it with one of those. So I would just now have one of those down there, just the 2 to the x, and then that'd be it. That'd be it. That easy. Simple. No, it's tough. I mean, there's a lot of stuff, and it's got those weird, but it's good. It's good to practice these derivatives, those regular derivatives of those different logs and exponentials that we have. Okay? All right. So let's look at the other website that we have, which is derivative practice number 2. And what this has is a bunch of different, it has 3 different practice tests. They're just PDFs. Okay? Now, they start pretty simply. Okay? Derivative of pi, what's the derivative of pi? 0. Okay, they start fairly simply, then they get a little more complicated, get into some quotient rules, get into some product rules. Here you got some e to the x's thrown in there. Okay, you got some that you could FOIL out first, probably be smarter to do that. You get some negative powers in there a little bit, right? You don't get anything too tricky. Then they get you a bonus here. They've got that one. Okay, so the derivative practice one. But again, you want to, I mean, don't overlook the basic ones, right? You want to practice some of the basic ones. You certainly don't want to do something stupid on an easy one, you know, and lose points there. Okay, then we get more into the chain rule on this worksheet. So you got power, you know, stuff raised to a power. You know, we spend a lot of time talking about the harder ones in class here. Now, I'm speaking to some of you that didn't do much homework here because, you know, some of you know as you did 10, 20 problems, you only had questions on a couple, right? And that's probably, well, hopefully the way the gateway test would be. For those of you watching the ones we're doing, you think the gateway test could be 10 of these. Well, it's not going to be 10 of like the one we just did. They're not going to be that hard. Of course, if you have no practice, they might all feel that hard. I don't know. But, you know, there's going to be a number of them like this. So you want to get these basic ones done. But right here, look at that, 2 to the 3x. So that's one of those you got to tack on the ln2, right? 2 raised to a power of x. So it's got some mixture, got some product rule, quotient rule. So they get a little trickier. Here you go with a cosine cube. So that's going to be a function in a function, and you start getting a little tougher with some of them here. Okay, and it gets into some of the trig ones. You got some arc sines down here at the bottom. You got an arc sine. You got a tangent. Okay, you got a secant, right? You got to know the derivative for secant. What is the derivative of secant? Better study the derivative of secant. It's secant times tangent. Secant times tangent is the derivative of secant. Okay, you get some more in here. Again, a lot of sines and cosines. Those we run into a lot. E's. There's a cotangent. There's a cosecant. Better study those rules. Okay. I only saw one arc sine or arc cosine on there. Okay, now what we haven't seen is any implicit differentiation. That other website did not have implicit differentiation on it, right? The mixture of the x and y's, where you got to tack on the y primes and solve for y prime. That's here in practice test number 3. Okay, so it starts out, it's got some product rules, got some more of the arc sine. Here it's got 10 raised to an x. There's an arc cosine, there's an arc tangent. There's an arc tangent. Now it mixes in some implicit differentiation. So there's not a lot of places to practice the implicit differentiation. Your book section we did, it had a few, but it didn't have very many. We did most of them. This website, page 195 doesn't have any. So this practice test number 3 on the website's got a few on it. Now, I think I would just make some up. You know, just make some up like what I was giving you the other day. X cubed plus 3x squared y. I always think it's good to multiply an x and a y because you got to remember to do product rule. Minus y cubed equals 17 or something. I mean, you can make those up all day long, okay? And then do them. And it's hard to check your answer. You probably have to bring them to me or check with each other, you know, and I could check it for you, okay? But there's an implicit differentiation right there. Here's an arc cosine. Here's an arc sine. Here's another implicit differentiation here. Here's another one down here. Here's an arc secant. Remember, that's the one we just said where you flip it. Probably not going to give you one of those anyway. Here's another implicit differentiation, although I'm probably not going to give you a division with that. We haven't done that. Here's another implicit at the end. Here's one a lot like we did in our homework, number 20 here. So you get some there at the end. All right, so you've got multiple places now to practice. So I'm going to let you have the rest of the time here, last 30 minutes, to work on that. And your assignment for Monday is to practice, practice, practice. Come with some questions, you know, and we'll work through a few more maybe. Give you some more work time, but then that gateway test is Tuesday. And remember, you want to be as prepared as possible. Maybe it's not good enough to get you to pass it the first time, but at least then you don't need a whole lot of practice because we're moving on to new stuff. So then at least you can pass the second or third attempt if you just clean up a few small mistakes you're making. Okay? All right. So you can go on you can get together in groups if you want to. You can get on the Chromebook, do stuff, page 195, whatever you think is the best use of your time. Again, doing a bunch of problems on page 195. If you do them on the website, I want you to write out your work, because when I come around Monday and look at homework, I just want you to see, you know, here's the problems I did. Here's the practice I did. I'm not going to give you a number. You do what you need to do. Okay? Let's just say by Monday, I would recommend you have more than a page worth of derivatives.
Yeah, so if you do quite nasty ones, there's a few problems.
Quite nasty. That's true. The quite nasties might take it. Depends how big you write. Some of you guys are getting. It's getting worse as I get older.
I wrote this one. I need like Chandler understands.
Yeah, like Chandler. I mean, Chandler could work 150 problems and fit it on half a page, probably. So, jeez.
What? Let me see. I don't even. You make it. Mine never good, but I still make that.